Welcome to Chapter 1, an introduction to Apache Iceberg. Here we explore why Iceberg exists. In this chapter, we will discuss why regular databases aren't ideal for analytics, and the evolution from data warehouse to data lake to data lakehouse. We'll also define what a table format is, discuss Hive's limitations, Iceberg's key features, and conclude with review questions. So let's start with a question. Why can't we just use a regular database for analytics? Think about it. You've got PostgreSQL or MySQL handling your day-to-day transactions, new orders coming in, customer updates, that sort of thing. These systems are amazing at quickly reading or writing one row at a time. But what happens when your boss asks, hey, what was our average revenue per customer last quarter? That's where things break down. Transactional databases store data row by row, which is great for finding one customer's record, but terrible when you need to aggregate a single column across millions of rows. You'd have to read every single row just to get one column's values. That's incredibly wasteful. This problem led to the creation of data warehouses. A data warehouse is a specialized system designed for exactly these kinds of analytical queries. It stores data in columns instead of rows, so grabbing all revenue values is lightning fast. It couples storage, compute, catalog, and file format, all into one tightly integrated system. Sounds perfect, right? Well, not quite. Here's the catch. Data warehouses lock your data into proprietary formats. Only that warehouse's engine can read it. Want to run machine learning on your data? You'll need to copy it somewhere else. Want to switch vendors? Good luck migrating petabytes of data. And the costs? They add up fast. So the industry said, okay, let's try something different. Let's just store everything cheaply on object storage, like Amazon S3, in open formats like Parquet. This became the data lake. Cheap, flexible, open. But it had its own problems. No ACID transactions, no consistency guarantees, poor performance. It was basically a dumping ground for files. And this is where the magic happens. What if we could get the best of both worlds? The openness and low cost of a data lake, combined with the performance and reliability of a data warehouse? That's the data lakehouse. And the key technology that makes it possible is the table format. A table format is a metadata layer on top of file storage that tracks which files belong to a table. This is what enables ACID properties, schema evolution, and time travel. This a key insight is that tracking individual files, rather than directories, unlocks everything. Now, the first table format was Hive. It defined a table as all the files in a directory. Simple, but deeply flawed. You couldn't atomically update multiple partitions. Concurrent writes were unsafe. And just listing the files in a directory to plan a query was painfully slow at scale. Enter Apache Iceberg. Created at Netflix in 2017 by Ryan Blue and Daniel Weeks, Iceberg took a fundamentally different approach. Instead of tracking directories, it tracks individual files. This one change unlocked everything. ACID transactions, time travel, schema evolution, partition evolution, and much more. Let me highlight the key features you need to remember. First, ACID transactions using optimistic concurrency control. Second, hidden partitioning, where users don't need to know how the table is partitioned. Third, partition evolution, letting you change partitioning without rewriting data. Fourth, time travel, querying the table as it was at any point in the past. And fifth, schema evolution, safely changing your table structure over time. Hidden partitioning in Iceberg matters because the old Hive way forced users to know and filter partition columns, making it error-prone and leading to costly full table scans when forgotten. Iceberg defines partitioning via source column plus transform, so the engine prunes partitions automatically based on natural user queries. Now let's test your understanding with some questions. I'll ask the question, give you a moment to think, then explain the answer. Question 1. What is the fundamental flaw in the Hive table format that Iceberg was designed to fix? Think about it for a moment. The answer is that Hive tracks tables as directories and subdirectories, not individual files. This directory-level granularity prevents atomic multi-partition updates, safe concurrent writes, and efficient query planning. Iceberg fixes this by defining tables as a canonical list of individual files. Question 2. What are the key differences between a data warehouse, a data lake, and a data lakehouse? Here's how to think about it. A data warehouse is a tightly coupled proprietary system. Great performance, but expensive and low. Question 3. What is hidden partitioning and why does it matter? The answer is that hidden partitioning means users don't need to know or filter by partition columns. In Iceberg, you define partitioning as a source column plus a transform, like hour of timestamp. The engine automatically prunes partitions based on natural filters. In Hive, you'd need to explicitly filter on a derived partition column, and forgetting to do so meant a full table scan. That wraps up Chapter 1. The Akin key takeaway is that Iceberg exists because the industry needed a way to get warehouse-like functionality on open, affordable data lake storage. And it achieves this by tracking tables at the file level rather than the directory level. In the next chapter, we'll dive deep into exactly how that architecture works.